Hey Mr. Grade, it's Grace. Today is the day we turn in our projects. And I wanted to say first of all, thank you for being a great teacher, for giving us help, for letting me take tests after the date when I needed to, and overall for being really lenient in general. But anyways, I did the cancer cell growth simulation, which is going to be backwards. But in the email I send you with this video, I'm going to send my attached spreadsheets that I worked on, just because I can't show them in the video. I printer things. But I will talk about them a lot. So, first things first, the exponential growth one. Followed the whole thing, and your question on here says, should your graph touch the x-axis? I said no, because I started with 3. And when I'm growing, I'm not going to go up from 3 and somehow touch down there. But yeah, you didn't really have many questions on my exponential growth, unless you count like models. My model, which initially like our layout for it was y equals c parenthesis 1 plus r n parenthesis to the t. And so mine was y equals 3 parenthesis 1 plus 0.2231 n parenthesis to the t, because the average rate of growth was about 22%, and t just kind of stays as a variable. And I did add model rows, but they're actually below the other percent increase area. It's not below the it's not below my original trials, just because I couldn't figure out how to move them all that way. And when I added the data for my model as a new curve on my graph, most of the lines were at or just like a little bit below my model, but I did have like 3 that were just outstandingly like way above it, reaching up to 100, but that's just kind of by chance. And then I predicted for, I am actually looking at the things right now, that's why I might look like I'm looking around in weird places. For like after round 25, my model predicted that I'd have about 461 pennies, and after round 50 I'd have about 70,830 pennies. So I'm really happy you didn't make us play that high. And after that we get to decay. So I of course did the decay procedure. That worked out. And you asked if my model should, or not my model, if my graph in general from the data I collected should touch the x-axis. And what I wanted to say about that is, if I had a model, like an exponential decay model as in a formula, then no, it shouldn't. But because this is literally me throwing pennies in the air from a cup, it actually will eventually touch the x-axis as soon as I get a heads, because all the heads died. And so eventually I got zeros when I was doing the actual experiment. But once I did the formula, which ended up being y equals 100 parenthesis 1 minus 0.24 n parenthesis to the t, that model actually wouldn't touch the x-axis, just because it's decaying exponentially, not linearly or anything. And when I added the data in my exponential decay model as a new curve on my graph, my model is actually way way above my other lines, because all my other lines actually ended up reaching 0 and generally went a lot faster. And formulas kind of changed. And then you had these discussion questions on the last page. The doubling time for my exponential growth model was 3.14 years. And I did that with the 70 divided by my rate of growth. You can see my math on here. Sorry, it's backwards, but I'll let you have a good look at it. And then my half-life, I got about 3 years by doing a different formula, which is -1 parenthesis ln parenthesis 2 end parenthesis over -0.24 end parenthesis end of the big parenthesis. And the 2 negatives cancel out, and then I got about 3. And then you gave us another exponential model, which is function x equals a times b to the kx. The A represents the initial value, and the B represents the rate, and the K represents time, I'm assuming. So yeah, that was my project, and thank you again, and I hope you have a great summer and a great rest of your year.